Yan. So, welcome back to my inangkid, the iMaths YouTube channel. So, for this video, we're going to be discussing the calculus of vector valued function, but please make sure na napanood nyo muna yung lecture video. Kung hindi pa, huwag niyong gagawin yung ginagawa nyo sa real life na hindi kayo papasok ng large class, papasok kayo ng discussion, no? So, basically here we're just gonna be practicing your calculus skills. So, ano ibig sabihin nun? Well, pag sinabi natin calculus, syempre we have three basic skills in mind. So, we have your limits, derivatives, and syempre, integrals. So, yun lang yung gagawin natin today. Basically, para lang tayong babalik ng Math 21. Kaya lang sa Math 21, we mess with real valued functions. Now, we get the limit, derivatives, and the integrals of real valued functions. Here, ang ating object of study are vector valued functions. We also get their limits, derivatives, and integrals. Game, limits. So, limits, sabi natin sa lecture video, yung limit ng isang vector valued function ay isang vector valued function na ang components ay or isang vector no, na ang components ay yung limit ng bawat component. So basically, you could think of it as parang dinistribute mo yung limit no, doon sa bawat component ng vector valued function mo. So this is the definition. Provided that the limit of each component exists. So, dapat yung limit ni x as t approaches a, limit ni y, limit ni z nag-exist. Otherwise, kapag may isang, at least one of them lang no, na hindi mag-exist sa tatlo, you already say that the limit of your entire vector valued function R does not exist. So, some notes lang in comparison to the limit of a real valued function sa Math 21. Kapag ang limit mo ay L, yung limit mo ay isang constant real number. Dito ang sagot, pag nag-limit ka ng vector valued function, is a constant vector. Kasi constant yung bawat component mo eh. Okay, so let's try to evaluate these limits no, to test our skills. Let's try this first. So we want to get the limit of this vector valued function as t approaches 2. So, sabi natin, ipasok lang natin yung limits. So, kinuha natin yung limit ng first, yung limit ng second, yung limit ng third. Itong una, yung limit nito as t approaches 2, you can just plug in 2, no? I think wala ka naman magiging problema. So, the limit is just the value at 2. Second component, very obvious. You can just plug in 2 to get the limit. So, third component, as t approaches 2, yung limit ng ln ng 1 over t is just ln of 1/2. Pwede mo lang din pong i-plug in si 2. So, simplifying that, kaya nyo na yan, malalaki na kayo, you get this as your limit. So, ganun lang po kadali. Let's try the same vector valued function, no? But this time, let's try to make t approach infinity. So, ganun ulit. Diretso na tayo ng konti. Hindi ko na kailangan i-distribute yung limit, no? Diretso na tayo sa next line. Kunin na natin yung limit agad ng bawat component. Yung first component, if you get the limit as t goes to infinity, well, you could do your, your old school way of multiplying 1 over t squared over 1 over t squared, or you could just look at the coefficients of the highest degree as t goes to infinity. You know that this goes to 1/3. Yung second component, pag pina-approach mo ng infinity yung t, obviously that goes to 0. Now look at your third component. If I try to make t go to infinity, yung loob ng ln, yung 1 over t, that will go to 0. In particular, that will go to 0 plus from positive values. No? Yung ln ng 0 plus, if you recall, that is negative infinity. So what can we say? Tandaan, no, kapag ang limit ng isang function ay infinity, that means na the limit does not exist, ha? So that means yung limit ng third component does not exist. Therefore, the limit of your entire vector valued function does not exist. Kasi may isang limit na hindi nag-exist, which is yung limit ng third component. Okay? Okay, good. Let's try this one. So, ginawa, nag-ano lang ako, no? Standard basis vector notation. So, sana masali na tayo dyan. Recall natin, ito lang yung ibig sabihin niya, no? Yung katabi na I hat, siya lang yung first component. Katabi ng j hat is your second. Katabi ng k hat is your third component. So, yung limit niyan, game. Limit ng first component, no? If we make tangent inverse of t go to negative infinity, tanda pa ba? Ano ang magiging limit? Limit yan is negative pi over 2. But, if you look at your second component, cosine going to negative infinity, it does not exist, no? So, you can stop right here. Wag mo nang kunin yung third component. Di mo na kailangan. Nakita mo na. Second component, limit does not exist. You can already stop right there and say that the limit of your vector valued function does not exist. Okay? Game. Last one. So, for this one, we want... siyasanay ko kayo na na gumamit ng standard basis vector notation. Ano ba? Nagre-record eh. Sorry. Sumamit ng standard basis vector notation. Kailangan masanay kayo dyan, no? Game. So, we want the limit of this as t goes to 1. First component, napakadali lang. Very obvious that you can just plug in 1 here. You'll get 3 or 3i hat for your first component. Second component, ano napapansin nyo? If you try to plug in 1 to get the limit of the second component, yung taas goes to ln 1, so that's 0. Yung baba goes to 0 as well, t squared minus 1. So basically, you have to use your L'Hopital's rule. So, kung kayang i-mental yung L'Hopital's rule and put the answer here already, that will be fine. But if you can't, okay lang din yun. You can do a side computation right here. So, ayan, sabi natin 0 over 0 yung kanyang form. So, we have to apply L'Hopital's. Again, kunin natin yung derivative ng numerator and your denominator. Do not apply quotient rule, no? So, yung limit ng taas, ln t, is just, or yung derivative ng taas, yung ln t ay 1 over t. Yung baba, magiging 2t. So, I think it's very easy now to plug in 1. Wala na tayong magiging problema. If you do, you'll get 1/2. So, 1/2 is the second component of your limit. Third component, very obvious na you can just plug in 1. You will have no problem. Diretso na natin. You'll have sine 2. So, the limit of this as t goes to 1 is the vector having 3, 1/2, and sine 2 as your components. So, when we study real valued functions or the limits of real valued functions, ano yung laging kasunod? Hindi natin may hiwalay lagi yung konsepto ng continuity. And you learned that sa vector valued function, you also have a concept of continuity. If you remember, for a real function f to be continuous, let's say at a point A, you have to satisfy 3 conditions. Una, dapat function value at A should exist. Pangalawa, the limit as t goes to A of f should exist. At pangatlo, yung limit na yon and yung function value should be equal. So, very, very similar lang, no, doon sa vector valued function. Ng isang vector function r will be continuous at t equals A if yung vector value at A exists, the limit as t approaches A ng R exists. Ito dapat kaya ng computin because we just practiced it a while ago. And of course, yung function value dapat equal dun sa limit as t approaches A. Okay? Let's try this example. We want to know if this vector valued function 5e to the minus t in cos t is continuous ln2. So again, we want to establish the three conditions. So yung una muna, function value at ln2, no? So ano yung function value niya at ln2? We just replace all t with ln2. When we do that, simplify natin ng konti para ma-compare natin sa limit. So, yung first component, well, it's just a constant 5. Itong e to the minus ln2, well, you've been exposed to that many times yung mga ganyang klase, no? You just put the negative doon sa taas ni 2, so you will get e ln 2 to the negative 1, or that's e ln 1 half dito. And then you can cancel e and ln by properties of ln. So you will have 1 half left. Itong cos ln 2, well, kung kayang i-mental, sure, you can put it straight here. But if not, again, you can do a side computation. Just remember that cos x is this, no? Definition po yan ng cos x. So, therefore, cos ln2 is just e to the ln2 plus e to the minus ln2 over 2. Itong e to the minus ln2, parang ginawa natin kanina, gawin natin e to the ln 1 half over 2. And then all the pairs of e and ln can cancel out. So, we will be left with this one, 2 plus 1 half plus 2, and simplifying that, kaya nyo na yan, I will not go into detail, that's 5/4. So, may function value ka, no? 5, 1 half, 5/4. So, first condition is satisfied. So, let's proceed. Second condition. Do we have the value for a limit, for the limit as t goes to ln2? Let's see. Pag pina-approach natin si t ng ln2 dito sa vector na to, diretso na natin. Sa first component, it's just a constant, no? So yung limit niya is just itself. Itong e to the minus t, if you let t approach ln2, basically you can just plug in ln2 here. So yung 1 half lang din kanina. And even sa third one, you can just plug in ln2 dito sa t. You will have a very good value. Wala kang magiging problema. You get yung 5/4 kanina. So, ayan. So, second condition is satisfied. No, we have a value for your limit. It exists. And furthermore, equal yung function value sa second component. Therefore, third condition is satisfied. We can say that the vector function r is continuous at t equals ln2. Okay, let's try this one. This is a piecewise defined vector valued function. We want to check its continuity at t equals 0. So game, very mechanical naman yung first step, no? You just plug in 0 to your vector valued function. So which one do we use? Sa dalawang vector valued function na to, by the way, hinalo-halo ko pala yung notations ng naka-bracket tsaka yung naka-standard basis vector. Maganda na masanay kayo using both notation, no? And hindi kayo malilito dapat. So, if you try to plug in 0, we will use this one, no? Kasi po, ito yung vector valued function for t equals 0. Diyan nagfo-fall si t equals 0. So, if you plug in t equals 0 here, yung first component, 0 plus 1 is just 1. So, first component is 1. Second component, yung taas is 0. Yung baba is negative 3. So, this whole second component is 0. Yung third component just becomes ln1, which is also 0. So, 1, 0, 0. Basically, we will be just left with 1, 0, 0 or I hat. So good, first condition satisfied. We have an existing function value para dito sa r of 0. Let's try to check your limit. So similar sa real valued functions, no? if we want to take the limit of a piecewise defined function doon sa breaking point, no, you cannot just take any of these two and take that as t goes to 0, no? Since magkaiba yung behavior for t less than 0 and for t greater than 0, you have to consider one-sided limits bago natin ma-compute yung limit as t goes to 0. So, first, limit from the left yung kunin natin. So, if we want to take the limit from the left nitong vector valued function na to, we will use, of course, the one corresponding for t less than 0. Yung limit niyan. Okay, kunin natin yung limit. First component, if you try to plug in 0, no, what do you get? You get sine 0 over 0. So that's 0 over 0. We might need to use L'Hopital's again. Kung kayang mag-mental, diretso yung value dito, that's fine. But if not, you can do side computation right here. Yung limit ng sine t over t as t goes to 0, you can apply L'Hopital's. Derivative ng sine t sa taas is just cosine t. Yung baba is just 1. So you're just left with limit of cosine t. Which, when, kung di yan, hindi ko sure hindi nyo, kung kita nyo. Anyway, if not, you can do that on your own naman. That's just, L'Hopital's rule. The answer is 1. Limit of cosine t na lang matitira as t goes to 0 from the left. So, 1 is your first component here. Yung second component, as we get the limit of t going to 0 from the left, you can just plug in 0. Wala tayong magiging problema. Now, for the third component, you have square root of t. It's very tempting to just plug in 0. Square root of t lang naman yan eh. But remember that the limit as t approaches 0 from the left ng square root of t, or if you have something of the form square root of 0 minus, what? Do you remember? It does not exist, right? Ang square root of t, wala siyang value less than 0. So, ibig sabihin, the limit of the third component does not exist. So, the limit as t approaches from the 0 from the left, ng third component does not exist. Therefore, yung limit ng r as t approaches 0 from the left does not exist. And furthermore, itong mismong limit na to, yung general limit as t approaches 0 does not exist. Wala na, hindi na nag-exist yung limit as t approaches 0 from the left. Hindi mo na kailangan i-check yung from the right, no? So, wala na. Tapos na tayo. Second condition, fails. Hindi na kailangan i-check yung third. Wala ka namang i-check sa third. So, you can just say that r is not continuous at t equals 0. Okay. So, now what will happen if we try to, get the same thing except na we switch this to vector valued function like this. Pero si 0, dito ko pa rin dinefine, no? Sa vector valued function na ito. So, what will happen? Let's see what will happen. So, if you try to get the function value, ito pa rin yan, no? Parang kanina, dito rin naman define si 0. So, ganun din dito. So, alam nyo na yan. Ganun pa din yan. I have. Dito pa rin siya ipa-plug in. Now, let's try to get the limit. Again, 0 is still a breaking point of your piecewise function. So, to get the limit, as t goes to 0, still have to consider limits from the left and from the right. If we try to get the limit from the left, which one do we use? This time, we will use this one. Siya na yung nakadefine sa t less than 0. This is very easy. I hat lang yan, no? You can verify. You can just plug in 0 sa bawat components to get your limit. No? So, first one, pag pinlagay mo si 0, wala magiging problema. Second one, you get 0 over negative 3. So 0 lang yun, and then third one is just ln 1. So I hat yung limit niya. Now, so far so good. We have to check the right-hand limit. Limit as t approaches 0 from the right. Of course, we use this one. And if we try to get the limit, yung first one, yan din naman yung kanina, kahit 0 from the right, maglo-L'Hopital's ka pa din, cosine t pa din yung lalabas, and you still get 1. Yung second component, as t goes to 0 from the right, again, you can just plug in 0, you'll get 0. Now, for the third component, this time, yung limit as t goes to 0 from the right ng square root of t, or square root of 0 plus, if you remember, that's already, yun na yung 0. So, this time, the limit as t approaches 0 from the right exists. And what can you say? Are these two equal? No? Yes, they are. No, iba lang ng notation, but they are the same vector. So, meaning, yung limit as t approaches 0, in general, of r of t is I hat. Or 1, 0, 0 if you want. So, second condition is satisfied. The limit finally existed. Moreover, yung function value and yung limit nag-equal. Therefore, when we change things up, this became continuous at t equals 0. Okay? Okay, good. Now, let's try this one. I think I have 3 more examples for continuity, but this one will be very quick. You'll see. First condition, we want to check pala if this vector valued function is continuous at 1. So we have to check first if r of 1 exists. Trying to replace all t with 1 here. Sa first component, kaya nyo na yan. You can see that it's 1 over 7. It's 2 over 14 actually. So 1 over 7. Second component, if you replace t with 1, excuse me, you get 1. But in the third component, if you try to plug in 1, yung denominator mo magzi-0. So, ano mangyayari? The function value for the third component does not exist. So, dyan pa lang, you can already stop. You don't have to check the second condition, the third condition. Function value does not exist. It fails. First condition pa lang, you can already say, hindi siya continuous at t equals 1. Okay, now let's try this one. Another piecewise defined vector valued function. Let's see if this is continuous at t equals -2. First, function value at -2 is explicitly defined. Sabi niya, kapag yung t mo -2, this is your value. No, -1, 3, 4. Yan yun. Now, we want to get the limit kasi satisfied yung first condition. So, second condition, does the limit exist? Check natin. When we take the limit of r, although this is the one defined for t equals -2, again, when we take the limit as t approaches a, we want the values of t getting closer and closer to a, but not necessarily at a. So, in this one, kahit pag-gaano siya kalapit sa -2, ang nag-hold na value is itong value sa taas. So, kahit ito, yung value niya at -2, when we take the limit as t goes to -2, we take this one. And when we do, ano mangyayari? Let's see. Let's try to take the limit. First component, you can just plug in -2, that's -1, so negative I hat. Second component, ano mangyayari? You can plug in -2 din. Wala yata magiging problema, no? Yung taas kasi magiging -t plus 1, so that's 2 plus 1, so that's 3. Yung baba, you have t squared minus 3, so that's 4 minus 3, that's 1. You get 3 here. Itong third component, if you try to plug in -2, yung baba, +1, yung taas, -4. you get negative 4. So, nag-exist, no? Yung limit, we have a value for your limit. Second condition is satisfied. However, if you compare the function value and the limit is not equal, no? Ayan. Yung third component siya nag-iba. If you check, yung third component, negative 4 sa limit, positive 4 sa function value. Therefore, it fails the third condition. It's not continuous at t equals negative 2. Okay? Now, let's try last one example. This is very familiar. Ito yung mga lumalabas sa exam, no? So, we want to find real numbers a and b such that this vector valued function now is continuous at t equals 1. So we want to establish continuity for this vector valued function at t equals 1. So we have to establish the three conditions. Game. Una, we want r of 1 to exist, but if you try to plug in 1 falls here, so we use this one. If you try to replace t with 1, first component becomes a, second component becomes 2b, third component becomes c. Next, we want to establish the existence of your limit, but this is a piecewise defined function breaking at 1. So if you want to check the limit at 1, you have to check limits from the left and from the right. So yung limit from the left, we use this one. I think it's very clear naman, no, na you can just plug in 1 to get the limit, no, kasi these are just polynomials yung each component. So he'll get this. Second component, limit as t approaches 1 from the right, we use this one. Again, very obvious. You can just plug in 1. You will have no problem. If you try to plug in 1 sa una, you'll get negative 2b. Sa pangalawa, if you try to replace t with 1, you get c plus 4. Sa pangatlo, yung t squared minus 1, magzi-0 yan. No? So, kahit ano man yung a na yan, you'll get 0 here. So again, we want to establish the existence of your limit. Gusto natin mag-exist to. Kailan nangyayari yun? Kapag equal yung limit from the left and from the right. So that happens kapag itong limit from the left, no, ay equal dito sa limit from the right. At kailan po ang dalawang vectors nag-equal? Kapag yung limit ng components mo ay equal. So dapat first components are equal, second components are equal, and third components are equal. And from that, you can already find the values of A and B and C, no? Yung sa third component pa lang, you can deduce that C is 0. Tapos, if you plug in here sa second component, if C equals 0, you get 2B equals 4 or B equals 2. And since A equals negative 2B, B equals 2 implies that A equals negative 4. Now, I'll leave the checking to you. If you plug in A, B, C with these values, you can see that this will satisfy the three conditions for continuity at t equals 1. Okay? So, before we end our discussion on continuity, just some observation, no? Pag nag-check tayo ng continuity, kapag may nag-fail na condition, no? Or kapag hindi siya continuous, kung mapapansin nyo, laging it's because of one of these three, no? Usually, at least one of these three, no? Kasi, in fact, no, nangyayari na yung R is continuous kapag continuous yung tatlo. All of them should be continuous. So, your vector valued function is continuous at A if each one of these three components is continuous at A. Tapos, this is continuous everywhere if this is continuous everywhere. So, kahit isa lang dyan sa tatlo ang hindi maging continuous, your entire vector valued function will already be not continuous. So, parang ini-inherit niya yung properties ng tatlong components mo. Okay? So, that's it for limits. Derivatives naman tayo. Pero naggutom ako, tenga kain muna ako.
Ayoko na! Tumigil ka na! Ayoko na! Ayoko na! Ayoko na!
Yan, I'm back. Kakain ko lang ng siomai, nagluto yung nanay ko. Tapos na-miss ko yung tipid 1 sa math. Pinanood ko yung video kanina, yung first part. Ang dami palang naririnig na manok tsaka na hangin, no? Pasensya na. I think tolerable naman though. Wala akong magagawa eh. So, okay, let's proceed now to your derivatives of vector valued function. So if you have a vector valued function like this, kanina sa limit, yung limit ng r equal sa components limit ng x, limit ng y, limit ng z. Ito, yung derivative ng r, ang components niya, derivative ng x, derivative ng y, derivative ng z. So parang sa limit, pwede mong isipin na dinistribute mo lang din yung derivative, no? Doon sa tatlo. Some observations lang. Yung sa math 21, no, sa real function, yung f prime of t, pag kinuha mo yung derivative ng isang real function, ang sagot real function pa din. Tapos kapag nag-plug in ka ng value, it becomes a real number. Sa vector valued function, ang derivative ng isang vector valued function ay isa pang vector valued function. Tapos syempre kapag nag-plug in ka ng value, you get a constant vector. But I think much more important comparison is that f prime of a, dati ni-interpret natin siya as the slope of tangent line to the graph of f at a. Yung r prime of a is the direction vector this time, no, of the tangent line to the graph of r at t equals a. So parang pwede mo isipin to as 3D version, no, ng tangent line mo. Game. So let's do just this example for your derivative. Dali lang naman. It's very mechanical. Just take the derivative of each of your component. Halimbawa, ito, yung derivative na to ay components having the derivative of sa components of r. Isa-isahin natin. Derivative ng tangent inverse, well, it's just 1 over 1 plus t squared. I hope you remember. Itong derivative ng t cosine t, product rule, no? Product rule tayo. Do you remember? Product rule. First component, no? Copy the first, so that's t. Derivative ng cosine is negative sine, so you get negative t sine t plus derivative ng first, which is 1, times derivative or copy the second, which is cosine, so you get plus cosine t. And then this one, pag differentiate ang negative square root of t, you'll get negative 1 over 2 square root of t. Sorry, square root of t po yan, hindi yan 2. Okay? Good. Now let's try more on the application side, no? So we need to find a vector equation for the tangent line to the graph of this vector valued function at t equals 0. So yun nga, sabi natin, the direction vector of the tangent line at t equals a is r prime of a. So here, we need to find the vector equation for the tangent line. Again, recall natin, you need two things to establish the equation of the tangent line or vector equation of the tangent line. You need a point in your line and a direction vector for your line. So first, kunin natin yung point in your line. Since this is the tangent line at t equals 0, a point in this tangent line is of course r of 0. Replacing all t with 0, you get this. This becomes 1. Ito magiging negative 2 cosine 0, that's negative 2. Ito ay square root of 4, magiging 2. So this is a point in our tangent line. Next, we want a direction vector. That's what's left for us to find. Again, yung direction vector ng tangent line at t equals 0 is r prime of 0. So, syempre, kailangan muna natin si r prime. R prime, let's write it straight, no? Let's differentiate each of these components. Yung e to the 2t, pag dinifferentiate, 2e to the 2t. Itong negative 2 cosine 3t, if you differentiate, cosine 3t becomes negative 3 sine 3t, may negative 2 ka nakasama dito. That's positive 6 sine 3t. This one, when differentiated, kaya nyo na yan, it's this one. So this is r prime of t. We want r prime of 0 for our direction vector. So doing so, replacing all t with 0, first component becomes 2e to the 0, that's 2 times 1. Ito, magzi-zero out lang to kaya wala kang j hat dito. Ito, if you replace t with 0, yung square root na yan magiging square root of 4 na lang, so 3 over 4. So yan, we're good. We have the point in the tangent line. We have a direction vector for your tangent line. Just recall that kung meron kang direction vector ABC at point in your line x0, y0, z0, then yung vector equation for a line is given this way: x0 plus at, y0 plus bt, z0 plus ct. So in this case, ang ating direction vector is yung r prime of 0. Ito po. Sinulat ko lang siya in bracket form, no? 2, 0, 3, 4. Tapos, itong x0, y0, z0, yung point in your tangent line is this 1, negative 2, 2. So, therefore, the vector equation of your tangent line, nakinig ba yung boss ko? The vector equation of your tangent line, x0 is a, or is 1 plus at, so that's 1 plus 2t for your first component. Second component is negative 2, nawala ako. Negative 2 plus 0t, so that's negative 2. Tapos, sa k hat, you get 2 z0 plus c, so 2 plus 3/4 t. So this is the vector equation for your tangent line. If you want to write it in bracket form, that will be fine too. That's also correct. So now let's go to your differentiation rules for vector valued functions. So yung differentiation rules niya sa Math 21, no, yung product rule, quotient rule, chain rule, they also have their equivalents here in vector valued functions. So if I have vector functions f and g and real function small f, then I have the following formulas. Yung derivative ng f plus g, derivative lang ng f plus derivative ng g, ganun din po sa difference. So very similar to your real function. And then if I have this real function small f times this vector function capital F, then yung sagot dyan is parang product rule lang. So copy the first, which is the real function, times derivative ng second, plus copy the second times derivative ng first. Very similar to your dot product, kaya lang po para siyang you just replace product with dot product. So yung sagot dyan is copy the first, dot product, derivative ng second, plus derivative ng first, dot product with the second. Cross product, very similar. First term is first cross product with the derivative the second, plus derivative ng first cross product with the second. Some notes lang po. If you have the dot product of two vector valued functions, the answer when you perform dot product between two vector valued function is a real function. Pero when you do cross product between two vector functions, you should get another vector function. Okay? And last one is yung parang chain rule natin, f, capital F composed with small f. Ito po yung kanyang derivative. Okay, let's try this using some examples. I have three vector valued functions f, g, and h, and I have small f, which is a real function. So let's compute for the following. Una, let's compute for f minus g prime of t. Sabi natin, ito po ay, ito yung formula, derivative ng f minus derivative ng g. We can compute outright, no? Itong derivative ng f, when you compute yung first component, ln t becomes 1 over t. 4 minus t squared becomes negative 2t at yung derivative po ng sinh ay cos t. So ito po, yung buong ito is your f prime minus your g prime. This is your g prime. Naka-standard basis vector notation siya, but gawin ko lang ano, no, para pareho sila. Gawin ko lang vector. Yung first component, ito yung derivative ng cosine inverse, if you remember. E to the 2t becomes 2e to the 2t and then negative 5. Yung third component ng g, so ang derivative niya ay 0 lang. So when you subtract, first component becomes this. So you have 1 over t minus negative ito. So you get 1 over t plus ito. Yung square root nawala, pasensya na. May square root yan dapat. Second component, negative 2t minus this one. So you get this. Third component is cos t minus 0. You get cos t. Or, another way you could do this, and this is just to show you, no, ano yung gaano kalaki yung difference when you perform the differentiation formula versus the actual thing that this says, no. Sinasabi kasi nito is, you want to differentiate the difference of f and g. So, ano kaya ang difference kapag imbes na gamitin natin itong f prime minus g prime, the differentiation rule, no? I-subtract muna natin sila. Tapos, tsaka natin kunin yung derivative. Let's see if there's a big difference in the difficulty of the process. So, doing that, subtract ko muna yung ano, no, f minus g. So, kunin ko yung derivative nung f minus g. Pag sinubtract ko yan, I get this for the first component, ln t minus cosine inverse, 4 minus t squared minus e to the 2t. Oops, bumaba si t. Sa taas dapat yan. Tapos, third component is sinh minus negative 5 or that's sinh plus 5. Derivative nito, nakalimutan ko yung dt dito. Pasensya na po. So, differentiating this, first component becomes derivative ng ln minus derivative nito. So, I get this one. Second component, ito 0, yung t squared magiging minus 2t, ito magiging ganito. And then yung sinh t plus 5, when you differentiate, it's just cos t. Pareho lang, syempre dapat, pareho lang naman. But there's not much difference, no, in the difficulty. So it's up to you what to use if you want to subtract first before differentiating, or if you want to do f prime minus g prime. However, if we try your second given, no, yung derivative ng f times h, let's see ano yung difference, no, if you do the differentiation rule versus doing or performing the operation inside first before differentiating. No, unahin natin yon. Perform ko muna yung f times h bago ko i-differentiate. So, I want to differentiate f times h here. Doing that, I get, pag dinistribute ko tong c1 over t plus 1, I get this one. And then, pag dinifferentiate ko siya, I have 3 quotients here. So, I have to use quotient rule 3 times here. Let's do it sa first one. Halimbawa, low d high. So, low, derivative ng tangent pi t ay pi second squared pi t minus high. Ito po, times the low, derivative ng t plus 1. Over low squared, you get this one. Tapos, quotient rule si other 2, malaki na kayo. Sa other 2, malaki na kayo. Kaya nyo na yan. So, I have this. So, anong difference? Well, here, I had to perform differentiation only thrice, no? Pero, ang pangit doon, yung tatlong bagay na din-differentiate ko are all complicated components. I have to perform quotient rule 3 times pa. Let's compare it as to using your formula, f prime times h plus f times h prime. Doing that, no, I have to differentiate h prime, which means differentiating 3 components, plus yung f prime, so that makes it 4 differentiation. But, maganda rito is, yung i-differentiate ko na 4 na yun, those are all simple terms. Hindi siya kasing komplikado nung sa kanina. So, if I have f prime here, I get 1 over t plus 1 squared for your f prime times h plus copy the f So, naging minus na siya times yung h prime when differentiated, negative tangent pi t, pag dinifferentiate is negative pi secant squared pi t, t cubed becomes, 3t squared, and cosecant t when differentiated is negative cosecant cotangent. And then the rest is just arithmetic. I'll distribute this here, and then add the 2. I'll get this answer. So, syempre, pareho lang yan dun sa kanina, but hindi ka tayo nahirapan mag-differentiate. So, still, most of the time, I will suggest for you to use the differentiation formulas. And that's the only thing I will be using for the rest of the examples. If you want to verify the other one, it's up to you. So, third one is the dot product. Again, yung formula niya is dot product ng f with h prime plus dot product ng f prime with h. Again, let's plug in. F is just this one. H prime, derivative nito, na-compute nyo na kanina to be this one. Plus F prime is also computed sa number 1. And H is this one. If you want to compute again, F prime and H prime, bahala kayo sa mga buhay nyo. Doing this, performing this operation, unahin natin yung dot products within the parentheses before adding the 2. So, doing that, I get, pag dinot product ko to, again, dot product, you just multiply component-wise, no? Multiply the first components plus product of the second components, this one times this one, plus product of the third component, so sinh t times ito, tapos yung dot product nitong second, yan lang din yun, product ng first component, plus product ng second component, plus product ng third components. Tapos yan na yun. If you want to simplify, sure, but this is already your answer, no? This is a real valued function. Sabi natin kanina, dapat ang sagot is a real valued function. So you have this as your answer. Next, let's try number 4. G cross product with h prime of t. So let's use our differentiation formula and plug in yung G, yung H prime computed na, yung G prime computed na rin kanina, and H is also computed. Kung nahihirapan pa kayo mag-dot product on one look, then you can use the table form, naka-columns, tapos do this takip-takip method. Pero ako, I will not be expounding on your computation that much. Kaya nyo na yan on your own. So, I will go by it briefly lang, no? So, yung dot product nitong first part, yung first term, so, e to the 2t times ito, minus itong negative 5 times 3t squared, so plus 15t squared pag minus siya. Second component, itong negative 5 times ito, minus itong cosine inverse t times itong negative pi secant squared pi t, or ito palang cosecant cotangent t, sorry. And then third component is cosine inverse times 3t squared plus negative pi secant squared pi t times e to the 2t. And then plus yung second dot cross product, I leave that to you. And then pag pinag-add mo yan, you'll get this very horrible answer. Okay, now let's go to your last example. I want derivative of f, capital F, composed with your small f. So, itong formula, yung first part ng product is f prime of f of t. Ang sinasabi nito is, you compute for f prime first, and then you plug in f of t. So, computing nyo muna sa f prime, tapos lahat ng t, palitan nyo nitong small f. Okay, iba siya, wag malilito hindi mo ipa-plug in ito and then differentiate. Kasi ito yun. Ito yun. Ito, ang gagawin mo, yung first product mo ay differentiate mo si capital F, i-plug in mo to, times derivative mo to. Okay? So, kung hindi kaya diretso mentally, pwede nyo munang computin si f prime of t, Separately, ito siya. Yung kanina na-compute na natin. Tapos, yung f prime of f of t, itong f prime of t, lahat ng t, papalitan ko lang nitong small f. So, I get this. Pagmilitan ko ito ng negative 1 over t plus 1 sa second component. I get this. Sa third component, I get this. Tapos, tsaka ko i-multiply yung f prime of t. Simplify lang natin ng konti. Pagandahin natin. Ito, tataas siya dito. Negative t plus 1. Ito, pasok ko lang, magiging positive. Ito siya pa din yan. And then, we're almost done. Just distribute this to the three components. You'll get your answer. Okay? So, that's it for your derivatives of your vector valued function. Last is your integral. No? Again, limit. Sabi natin, limit ng r is limit ng x, limit ng y, limit ng z. Derivative ng r, ang components, derivative ni x, derivative ni y, derivative ni c. Integrals, ganun din po. Kapag definite, lagyan mo lang ng bounds, ganun pa din yung formula. Again, you could think of it as distributing the integral doon sa components. So, syempre, if you take the indefinite integral of r, you will get a vector function. But if you get the definite integral of r, lahat ng ito magiging constant, itong tatlo, you get a constant vector. Okay. Let's evaluate some integrals. Halimbawa po, ito, evaluate natin. This is an indefinite integral. So, sabi natin, ipapasok lang natin yung integral doon sa tatlong component. And let's compute the integral of each one. Itong una, 1 over 7t plus 4. It's of the form 1 over u, where you let u to be 7t plus 4. So, ln lang yung integral niyan. Ln absolute value ng ilalim. Pero since you let u to be this, your dt is 7 du. So, I need a 1 over 7 here. Plus t to the fifth, or plus c1 don't forget plus c1. Since this is an indefinite integral, so first component, you get an arbitrary constant here, c1. Second one, t to the fifth, when you integrate, that's just t to the sixth over 6 plus another arbitrary constant for your second component. Itong third one, well, yung iba memorize na yung integral na yan. If not, that you can always perform integration by parts. Applying your Liate prioritization, you get u as your t, dv as your e to the t dt. So, I have this. So, pwede mong ibukod yung computation ng mismong indefinite integral na to, tapos isalpak mo na lang dito, or you could continue the lines of your solution like this. So, this is uv. This part becomes uv minus integral ng v du. And then, continue your solution. Copy lang natin itong dalawa. Ito, kaya na nating simplify. Integral ng e to the t is e to the t lang naman. So, I have this plus c3. Okay? Or, another way to write your solution is, yung mga c1, c2, c3, ito pala, wag muna nating idagdag, But instead, after we're done computing, we add an arbitrary constant vector, c hat. Yan. Gets? Okay, good. Now, let's try a definite integral this time. So, definite integral nito, ipapasok lang natin isa-isa. Okay. Simplify lang natin itong second term. Nakita nyo na, na-spoil na kayo. Para mas ma-integrate natin siya ng maayos, you can separate the cosine squared into two cosines sa ilalim. So, you have sine over cosine times 1 over cosine. That's second tangent. Tapos, yung 4 dito. And then, hello! And then, you can now distribute the integral for this. Itong first integral, Very familiar, ang integral lang ng 1 over 1 plus t squared is just your tangent inverse, but this time we'll evaluate it from 0 to pi over 4. Pag in-integrate ko naman yung second term, second t tangent t is just second t, evaluated from 0 to pi over 4, at ang integral po ng 4 is just 4t from 0 to pi over 4. So, evaluating each of these three, yung tangent inverse ng t sa pi over 4, it becomes 1. Sa tangent inverse ng 0, it's just 0, so it's just 1 for the first component. Second component, you get second pi over 4, that square root of 2, second 0 is 1, so square root of 2 minus 1 here. Dito, at pi over 4, you get pi, minus 0, you get pi. So this is your answer. Or another way to write this, ito ang ginawa natin, distribute natin yung definite integral at sa tatlo, tapos bawat isang component in-evaluate natin from 0 to pi over 4. Another way to write your solution is, after this step, is evaluate the entire vector valued function from 0 to pi over 4 imbes na isa-isa. Okay lang din yan. So when you evaluate this whole thing first at pi over 4, you get this vector. At pag in-evaluate mo sa 0, you get this vector. So, you should get the same thing. Either way works. Okay? Now for our last example for this discussion. Last na lang eh. Okay, so let's have this. So, we are asked to find a vector valued function given sa atin yung derivative niya and a condition that r of 1 is equal to this. So, one clue that we have is we're given the derivative, no? So, yung r is equal sa integral ng derivative niya. So, to get the value of r, we just integrate r prime. Doing so, I get, tuloy ko na to ha. So, doing so, pag in-integrate natin yung first one, that's 2 times t to the negative 3. So, that's 2 times t to the negative 2 over negative 2, or negative 1 over t squared. Square root of t is just t to the 1/2. So you get this one.
Ayoko na! Tumigil ka na!
Again, yan. Wala na yung tindero ng gulay. Naalala ko tuloy yung yung nagbebenta ng repolyo sa Avatar. Anyway, so as ito, if you let u to be 2 minus t, you'll get ln 2 minus t, pero may times negative 1 ka, kasi minus t ito, may negative ka dito, babalik ka sa positive. Positive siya dapat. ln 2 minus t. Okay? But this is not yet your r, no? Kasi you have arbitrary constant c1, c2, c3. So to get the vector valued function r, you have to identify what these corresponding constants are. At dyan papasok yung role ni r of 1. So if because of this condition we have in our given, r of 1, ito yung r of t natin, sabi natin, di ba? So if I plug in 1 doon sa mga t, I get this. Ito magiging negative 1 plus c1, ito 2/3 plus 2/3 times 1. Ito kahit positive to, dapat either way naman 0 lang tong term na to. So you'll get c3 kasi ln 1 ito eh. So this should be equal to this according to our given, but r of 1 from our computation is this one. So we have three equations involving c1, c2, and c3. We can find the values of c1, c2, and c3. First components being equal, I have this. This means that my c1 is 0. 1/3 should be equal to 2/3 plus c2. Transposing 2/3 sa kabila, I get c2 equals negative 1/3. And lastly, I have C3 equals 6 very explicitly stated dito. So yan, you have C1, C2, C3. Yung mga C1, C2, C3 sa R of t kanina, palitan mo lang ng mga na-compute mo, you now have your value for R of t. Okay? And that's it for your discussion for the calculus of vector valued functions.